as we look at section 3 in the unit circle, we're going to use the unit circle to determine the measurement of the sides of a right triangle. So anytime you're using the unit circle, if the angle that you're looking for or that you're given is greater than 90 degrees, then you're going to have to use the reference angle. So you're going to have to take the difference between the terminal side of that angle and the x-axis. So we have a couple examples here on the screen, and of course we have the unit circle. Familiarize yourself as you're looking at this and make sure you recognize where these values come from. These angles that you see in quadrants 2, 3, and 4, they're all the same values as the angles in quadrant 1, it's just that they have different signs. If you notice, the signs change when you go to quadrant 2, quadrant 3, and quadrant 4 because x and y changes positive or negatively. So as we're looking at this, and we have a couple problems here, sine of 45 degrees. Let's look at the first one. So find 45 in quadrant 1, and it would be this angle here. And we're already given on the unit circle the x and y value at that point on the unit circle. So if you remember, the first value, the x, is the cosine. The second value, the y value, is the sine, and the reason we can assign that because the hypotenuse would be length of 1 because it's on the unit circle. So every point on the circle is equidistant from the center of the graph or the origin. So that's why we can assign x and y to sine and cosine. So sine is going to be the y value, so sine of 45 degrees is square root of 2 over 2. Also, the second problem, secant of 300 degrees. Remember, secant is the inverse of cosine. So we need to find the cosine value at 300 degrees. So we go to 300 and we look for the cosine value. The cosine value is 1/2. So that means the secant is the inverse or the reciprocal of 1 over 2. So the secant of 300 degrees is 2. Now sometimes when you're working these, especially when you get to cosecant, secant, and cotangent, when you have to take the reciprocals, when you flip these over, if you end up with a radical in the denominator, then you have to make sure and remove it. That's something we've been working on, and that's also on the 5-2 lesson here on YouTube. So make sure you take a look at that and make sure that you can remove any radicals that are in the denominator. The second part of 5-3 is to take a point that's not on the unit circle, and how do we determine what those values are for those measurements. So let's pick a point at random, let's say 3, -2. So this is our given point. We have a formula to use the x and y value to find the length of the hypotenuse. And that formula is r equals square root of x squared plus y squared. So we can plug these values in and we can determine the length. The r is going to be the length of the hypotenuse. Since remember, this is not on the unit circle. This point is outside or maybe inside the unit circle. So r is going to be equal to square root of 3 squared plus -2 quantity squared. So make sure you put it in that way in your calculator. If you put -2 squared, you're going to get a negative number. R equals the square root of 9 plus 4. So r is equal to square root of 13. We can't do anything about square root of 13. We can't reduce it, can't change it, so it is what it is. So our cosine for this one is going to be 3. Sine is going to be -2, and the hypotenuse is the square root of 13. So we can go ahead and calculate sine -2 over square root of 13. And why do we write that way? Remember, this is not on the unit circle, so we can't have a 1 for the denominator. Cosine is going to be 3 over square root of 13, and tangent is going to be negative 2/3. That's sine over cosine. So that gives us a basis to find these values. Remember, when you have a radical in the denominator, like we do for sine and cosine, you have to remove that radical. So let's look at that quickly as we end this. To remove the radical, you will multiply by the radical over the radical. Remember, that's effectively a 1. So multiplying these together, we have negative 2 square root of 13. And then in the denominator, we have square root of 13 times square root of 13. That's just the number 13. We cannot reduce negative 2 over 13, so that is our final answer. So to fully get the answer is negative 2 square root of 13 over 13. As you do more of these, it will become easier and easier, so make sure you're practicing these problems, and you'll have it down in no time.